Hey everybody, this next video lesson I'm going to talk about the factors that affect temperature change of an object. Let's say, for example, you have an object like a piece of metal. What things do you need to consider in order to accurately predict what the temperature change? And in fact, I'll show you how you can calculate using math a temperature change of a chunk of metal or some water, but you need to know a little bit of information about the substance before you can calculate the temperature change. So let's just first talk about the factors that come into play when you're looking at changing the temperature of an object. First, let's talk about temperature change. In order to identify or signify temperature change in these problems that we're going to see in a little bit, I'm going to show you something called delta T. Delta, the symbol, is a triangle that comes in front of a capital T. The delta means change in temperature. Now, if delta T is positive, then you're looking at something heating up or the temperature changing in a positive way. So it's getting hotter. Now, if you see a negative delta T, then you'll recognize this as a situation where a substance is cooling down or the temperature is becoming smaller. So a positive delta T means heating up and a negative delta T means cooling down. Now, we discussed in a previous video lesson that a temperature and heat aren't exactly the same thing. Temperature is measured in degrees Celsius, whereas heat is not measured in degrees Celsius because heat is how much energy there is in a substance, not how fast the particles are moving. But the more energy you put into a substance, the faster the particles move. And so they're closely related to each other. And I said you could think of heat and temperature as the same thing, but they're not. In fact, heat has its own unit of measurement, and the unit of heat is called the joule. A joule of energy or a joule of heat is a quantity of heat. Kind of like a dollar is a quantity of money. Well, a joule is a quantity of heat. And if you add more joules to something like this metallic substance up here, then you are adding more temperature. The more joules you add, the higher the temperature. And so to summarize, heat and temperature are not the same thing because they're measured different ways. Temperature is a measure of how fast the particles are moving. Heat is a measure of how much energy a substance has. But if there is more heat, there's more temperature. Add more joules, increase the degrees Celsius. And if you remove the heat, then you lower the degrees Celsius. Notice how I represented the loss of energy as a negative energy. So if we add energy, that's plus joules, and if we remove energy, that's negative joules. And if we add joules, we have a positive change in temperature, and if we remove joules, we have a negative change in temperature. The amount of joules of energy is not the only factor that we need to consider when talking about how much a temperature will change. Of course, adding more energy means the temperature will go up. But what about the mass? Mass is a measure of how much stuff there is in a particular sample. Mass is measured in grams, and the more mass you have, the more amount of stuff you have. And so a large pile has a large mass and a low pile has a small mass. Once again, mass is always measured in the unit known as grams. Let's take, for example, a situation where you have 2 cups of water. 1 cup of water has approximately 50 grams inside the cup, and the other cup of water has approximately 100 grams inside of it. Now you take both of these cups and you put them into the microwave at the same time, and you warm them up equally, and so they're both subjected to the same energy source. After about a minute in the microwave, you take the 2 cups out and you take the temperature. Now, what would you predict the temperatures compared to each other? Will the cup with 50 grams of water have a higher temperature or a lower temperature compared to the one with 100 grams of water? Well, if you thought about this and you predicted that it would be higher, you would be correct, because the smaller amount of mass will see a greater increase in temperature. Just like when you take something out of the fridge. Let's say you had a big tub of mashed potatoes and you want to heat some up in the microwave. Do you heat up the whole tub, or do you take a little bit out and put it on a plate and heat up the smaller amount? The smaller amount, it takes less energy to make the temperature go up. If you want to heat it up so that it's edible rather than refrigerator temperature, you don't want a whole bunch of mashed potatoes on your plate. You want just a little bit. And to heat it up even faster, you might take that little bit and split them up into even smaller piles. You see, the smaller the pile, or the smaller the mass, of the substance you're trying to heat up, the faster it'll heat up. And so mass plays a big factor. Smaller the mass, the higher the change in temperature. The bigger the mass, the lower the change in temperature. The last thing that we need to consider before we get into the calculation part of the video lesson is what effect does a type of substance have on the change in temperature? This time, let's consider two different types of substances. In my last example, I talked about both being water and we had different masses, but now we're going to keep the mass the same. So on one side, we're going to have 50 grams of metal and then 50 grams of water, and we're both going to heat these up equally. We're going to put them in the oven because you never want to put metal in the microwave. So let's turn on the oven so that it's really hot and put both of them in the oven for approximately 2 minutes. Now after 2 minutes, I'm going to take them out and I'm going to measure the temperature of each one. Now they're not going to have the same temperature because they're not the same substance. You see, different substances have something called a C value, and the C value is a number that tells us how fast something heats up. We all know there's things called insulators that you use to grab hot objects. If you've ever done any baking before, you usually put a pot holder on your hand and grab the hot pan out of the oven so you don't burn your fingers. Because if you put your hand on the metal, it's going to be really hot. So this insulator is something that has a C value that doesn't heat up very fast so that you can touch it without burning yourself. A C value is a number that tells us, once again, how fast something heats up. The two substances that we're going to talk about, one is a metal and the other is water. Now, metal has a very low C value compared to water, which has a very high C value. Now, which of these two would be the warmest after you take them out of the oven? Now, the metal, since it has a low C value, you might think it would be safer, but in fact it is not. The one that has the lower C value, in fact, heats up faster and has a higher change in temperature. Small C values result in large changes in temperature, but a high C value results in a lower change in temperature. So in fact, after a minute in a hot oven, water would be safe to touch, but the piece of metal would probably be too incredibly hot to touch and you would hurt yourself. So the type of substance is a factor. And this C value is something that's always going to be given to you. Every substance has a C value. And just to give you an idea, let's just say the metal is aluminum. Its C value is 0.897. Water, on the other hand, has a C value of 4.18. Now, as I said before, a small C value heats up fast or heats up quickly, where a large C value heats up slowly. So your insulators for heat that don't heat up very fast oftentimes have high C values, things like water or plastic. These are high C value. Things with low C values are things like metals, copper, aluminum, tin. And pans are made out of metal because they have low C values and allow the food to cook inside the pan much faster than it would if it were made of plastic. So in summary, something with a large C value heats up slowly and something with a low C value heats up quickly. Now let's put it all together. I will show you the formula for the calculation in order to figure out how much temperature change something would happen if we factor in the amount of heat, the mass, and the C value of that substance. So once again, let's list the four variables down here on the left. We've got the change in temperature, which is measured in degrees Celsius. If that number is positive, that means it's heating up, and if it's negative, that means it's cooling down. Joules, which is measured of heat. You've got grams, which is a measure of mass, and you've got a C value. Once again, that C value tells you how quickly something heats up or cools down. Something with a large C value heats up slowly, and something with a low C value heats up quickly. The formula that we use these four variables in looks like this. On one side of the equal sign, we put delta T over 1. And on the other side of the equal sign, we put joules divided by grams times the C value. Notice once again, we've got basically two fractions on either side of the equal sign, just like we did with the combined gas law in the last chapter. We've got a top and a bottom on the left, and we got a top and a bottom on the right. So just like the combined gas law problems, we're going to follow the same set of 5 steps. We are first going to write out the law. It's no longer a gas law, it's one that represents temperature change with energy and mass and C value. but you write down the mathematical formula first. Then we're going to list the variables down the left. But unlike in the gas law, none of these variables are going to be held constant. And so we can skip the part where it says hold a variable constant. So we write down the law in step 1. Number 2, list the variables down the left. Step 3, substitute the numbers in to the law. Step 4 then would be cross multiply and divide, solving for the variable that you don't know. Because in the problems that you're going to see, you're going to know 3 out of these 4 numbers, and you're going to have to solve for the missing number. And we can use cross multiply and divide just like we did with the gas law. Here's a problem similar to the ones that you'll be expected to solve on the upcoming practice problems and quizzes and tests. Let's read it together. 40 grams of water gains plus 500 joules of energy. Now in these problems, there's going to be a plus or a minus in front of the joules of energy. Plus means that the energy is being added or it's endothermic, and negative means that the energy is being lost or it's exothermic. So in this case, you are adding 500 joules. If the C value of water is 4.18, what is the delta T of the water? So like we did before, we're going to jot down the law, or in this case, the formula. And once again, it's delta T over 1 equals joules over grams times C value. Now down the left, I'm going to list the variables. Delta T, joule, grams, C value. And I'm going to identify each one of these. The delta T is my unknown. It says what is the delta T? So I don't know that, so I'm going to call it X. Joules is plus 500. That's right here. The grams, which you find right here, is 40. And the C value is 4.18. Now I'm going to take each one of these and I'm going to plug it into this formula and solve for the missing variable. So delta T is X, and that's over 1. And that's going to be equal to 500 on top. And then underneath, I'm going to do 40 times 4.18. Now I need to cross multiply and divide. So I've got 1 times 500, or 500, and set that equal to X times 40 times 4.18. Because I'm going to take the top left and the bottom right and multiply them together. Now I have everything all on one line. I got rid of the denominator. I got rid of the bottom of the fraction. By cross multiplying, I got rid of everything and put it all on one line. Now I'm going to take and I'm going to find and isolate X. So I'm going to multiply these two numbers together, and that number is going to equal 167.2. Now that's still multiplied by X, and on this side we still have 500. I just took these two numbers and I multiplied them together. Now I'm going to isolate X by dividing by 167.2 on each side. That eliminates 167 and gets X by itself. And if I take 500 and divide by 167.2, I get an answer of 2.99, and since it's a delta T, the answer is in degrees Celsius. So in summary, I started with the formula, I listed my variables down the left, I plugged everything into the formula. As you can see here, I did cross multiply and to get everything on one line, and then I did the math where I divided by a number on each side where the X is to isolate X, and got my final answer of 2.99, and I labeled my answer degrees Celsius. Here's another example, and this time we're going to solve for a different variable. Once again, we're going to start with the formula on the left-hand side, which once again is delta T over 1 equals joules over grams times the C value. So now I list my variables down the left. Delta T is something, joules, grams, and the C value. Now this time I have the delta T, and you can see that it's negative 20 degrees Celsius because it's cooling down, so it has a negative change in temperature. That happens. You can have negative changes in temperature, and you can also have negative joules. So if we have negative 900 joules of energy in this case as well, because the energy was lost. It was exothermic, it was energy given off. What is the mass if the C value, which was listed in the first part of this sentence, is 0.354? Now I'm going to take these numbers and plug them in over here. So The delta T is negative 20, and that's over 1. Now the joules is negative 900 on top, and then the grams is my unknown, and I'm going to multiply that by 0.354 on the bottom. Now, like I did before, I'm going to cross multiply and divide. So I'm going to take 1 times negative 900, and anything times 1 is itself. So negative 900 is equal to negative 20 times x times 0.354. Now what I'm going to do is I'm going to multiply negative 20 times 0.354, and we'll figure out what that number is. If I multiply negative 20 times 0.354, I get negative 7.08. Now that's still times x, and that's still equal to negative 900. Once again, I just took the 20 and multiplied it by this so that I could combine those two numbers together. Now I need to isolate x, so I'm going to divide by negative 7.08 on each side. Divide by negative 7.08. And when I take 900 and divide by 7.08, I get an answer of 127.12 grams. And that is the mass of this piece of metal. Once again, I started with the formula. I listed my variables down the left. I used the problem to fill in what I know and find out what I don't know. It'll always say something is unknown, and it says, what is the mass? So that's how I know that I'm solving for grams. I have a C value, I have a delta T, and I have a joules, so those are all plugged in. Anyway, I take those and I plug them into the formula. I put my numbers in, I cross multiply, so I get everything on one line, and then I solve for x. I multiply the two numbers together that are both on the same side as x. That was 7.08. It was negative, so negative 7.08 times x equals negative 900. Then I divided by that number on each side. That got rid of the negative sign because a negative divided by a negative is always a positive. And then 900 divided by 7.08 is this answer in grams. So I solved for grams. Anyway, that takes care of this video lesson. Thanks for watching.